everybody, and welcome to another exciting, fun-filled, hair-raising episode of Radiorama, where, as the name implies, I show you how to work on radios. This ain't a radio, it's a television set. It's a RCA Deluxe Portable. I didn't look up the model number, but it's, I'm guessing probably from the mid-50s. Working condition unknown. It was part of an estate that we got recently, and the gentleman worked at, I think he worked at a TV station, which is interesting because on the back it says SJSC TV. So I'm not sure if this was property of the television station or, I don't know, San Jose State College or something. Who knows? $4.92. Because it's not been on for who knows how many decades, I'm going to bring it up very slowly. My Variac. Also, my Variac has a amp meter in it, and if there's going to be a short, you'll know because it'll start whacking, the meter will start jumping over to the right. And you can see we're bringing it up slowly, and that needle continues to fall for a little bit. Anyway, let's see what I'm not going to film this, but what I'm going to do is over the next 10 or 15 minutes, I'm going to bring it up incrementally, 10% at a time. And what we're doing is reforming the capacitors that are in it. If you bring it up real quick, you might just short them things out. And this is a hot chassis television. It weighs hardly anything. There's no power transformer in it. So we want to be mindful of that. I also want to see if the CRT is any good. If the CRT is bad, then this is going to be a no-go. No one remanufactures CRTs anymore. And so restoring televisions is a little more challenging than radios because of the relative obscurity and rarity of getting CRTs, even though getting this one might be a little more easily had, but I won't. And the reason is because, for whatever reason, the value of these is basically nil. I'm just doing this because I wanted to do something different. This is for my own entertainment purposes. We might keep it for the museum, or I don't know. I'll need to get a digital converter to get a picture on it because this is, obviously, it's analog. So if there's anything we're going to see on this, it's just going to be a bunch of snow. Let's see. Make sure it's still not drawing much. Not drawing much at all. That's good. It's settling down nicely. Like I said, I'm just going to bring it up very slowly. We'll see what happens. All right, I'm not sure how this is going to look on video because obviously the picture is out of sync with my video camera, but it's not rolling like this on video. We've got a good solid screen here. Audio's working. Obviously, we've got some dirty pots here. It's a good solid raster there. What I wonder is if it was used either in a school or at a TV station. Maybe it didn't have that many hours on it. I'll go ahead and turn it off. I'm trying to remember if you see a dot for a long time, whether that means the CRT is on its way out or not. It's been a while since I've worked on TV. But before I continue, there's a few very important things to remember. TVs, their CRTs operate on really high voltages, as in, this being black and white, it's anywhere from, like, I don't know, 8 to 12 to 14,000 volts. And that's going to the anode, which is on the side of the set. Now, it's very important to understand that even when this is unplugged, and even if it's been off for a very long time, that the CRT is going to hold a charge. And that CRT, it will absolutely unleash all of its contents on you if you touch it the wrong way. So it's very important to discharge them. The other thing too is that the reason that there's a piece of plexiglass in front of the CRT is because they hadn't quite figured out implosion technology, how to make these things implode safely. So if they imploded, it'd come blasting out of the front of the TV. So this glass or this plastic in front of this is to make sure that if that happened, it's not going to shoot into the living room. So just be aware of that. I don't recommend people work on televisions if they are new to electronics. There's a lot of things that can hurt you here. So just a word of caution. I've never shocked myself with the CRT, but I have a friend who did. He was carrying a monitor across the room. It jolted him. He let go of it. Luckily, it was right next to a couch, so it bounced onto the couch and not onto the floor. Dangerous shit. So just be aware of that. Especially if it's color television, that's even more dangerous. That requires more voltages to fire the CRT. So I'm going to remove the back and see about discharging it before we get to work on it. All right, so I removed the back, and like I said, this is a hot chassis set, and what they've done here is the guts are insulated physically from the chassis either via this paperboard up here or with nylon spacers as seen there. I cannot get to the anode of the CRT. I think I'm going to have to pull the entire thing out because I want to discharge that before I do anything. Because like I said, that can be nasty. I did read something, and I'm not sure if I take it as a grain of salt, that said that yes, you can get jolted real bad by these things, but when it's unplugged, and if you do manage to get zapped, it's not going to exactly be lethal. It's just going to hurt. But I'm not recommending that anyone take a chance on that. I have to figure out how to disassemble this thing. It looks like I'm going to remove the front here and see if there's anything holding the CRT in, like some springs. And I'm hoping this should either push out or slide back. Probably it'll push out through the front. But we'll need to make sure and disconnect everything. We have two big electrolytic cans here. They have multiple values inside. They're probably high value, as in like multiple hundreds of microfarads. I'm hoping not, but if they are, I'll have to do something creative about that. I also have my component checker. I'm going to check the value of these guys to see if they're at all good, because just because you have old electrolytics in something does not necessarily mean they are bad. I'm recently getting into the habit of just checking electrolytics before I go gung-ho. On the other hand, these paper caps here, there's a few orange drops, but not many. These need to be replaced. So too did these. These are called Bumblebee caps, and they're also paper, but they just so happen to be in a Bakelite case. They're leaky, not to be trusted. They should be replaced. I'm hoping there's not a lot of caps in this thing to replace. This is pretty late for TVs compared to what we usually work on at the museum. Be very mindful of this. If you crack that neck, you're screwed. It's got an RCA emblem on it, so it's probably the original RCA tube. Picture tubes did not have near as long of a life expectancy. You were good for maybe a few years. And let's see. It's got a fuse here. I'm glad that fuse isn't blown because those are hard to find now. Looks like some of the spray paint that they spray painted the back with got on this tube. It's probably, that looks like the rectifier. There's the tube coming off the flyback. Flyback is in here. And the flyback is obviously good, or the set wouldn't work. But if you ever look at these things and they look all gooey and melty, that's often not unusual, so don't panic about it. It doesn't automatically mean they're bad. So let's get to work here. I need to unplug this speaker, take the knobs off, remove some screws, remove the front, and see if I can get this thing out of the case. Now I took the trim ring off the front here, and it looks like this protective glass or plastic is held in with these screws all around. I'll take that front off and see what the situation with the CRT and if there's any hardware holding it in place. Well, it turns out the entire CRT is affixed to this front. So what I'm going to have to do is disconnect the yoke, not the yoke, but the all the crap that's connected to the back of the CRT. I am not a TV person, so all of you snickering, go ahead. I haven't worked on a TV in a few years. So let me see about disconnecting this guy. I definitely, again, want to discharge it so I don't shock the crap out of myself, which would be very unpleasant on a Sunday morning. All right, I've gotten this far. I was able to pull the yoke off. The chassis is now loose. It'll come out in one piece. But I can't get to the anode cable, so I'm going to see if I can pull the CRT out a little bit, just enough for me to discharge and loosen it. That's the only thing holding the chassis in, and I don't want to yank on anything because there's a lot of sensitive things here. I'm going to probably wrap this up in a plastic bag to make sure I don't break any of those leads, because that would be unfortunate. Getting one of these would be not easy if I broke anything. Okay, I'm finally able to get to the anode. What I'm going to do is I've got this attached to ground. Reach in here and touch the anode. It's not doing anything. Probably had very little charge on it. But I just wanted to make sure. It'd be very unpleasant to shock myself. Alright. Let's make sure I touch it a whole bunch more times, then we can pry that off of there, and then we can pull the entire CRT out. And we can push the chassis out the other way. Alright, so the guts came out all in one piece. And we have lots of stuff to replace here. We need to replace a bunch of stuff on this board. These guys are brown / orange drops. Those are okay, but this, and 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 this need to be replaced. And underneath we have a bunch of other goodies. All of these guys should be replaced. And of course we got this guy here. 150 microfarads, 200 working volts. Got these all the selenium rectifiers. Probably just leave those alone. And we have these electrolytics here. And what does it say? 150 microfarads, 350 volts. There's just one value there, and there's 3 values here. And it's hard to read. I'm not going to try to force you to see that, but I'm going to have to get the values off of that. But just for giggles, I'm going to see what the quality of this electrolytic is. I'm going to use my little multifunction tester to see if it still in fact measures 150 microfarads and see what its loss and leakage is. Alright, right off the bat, this capacitor is testing very bad. It is testing at 220 microfarads, which isn't a problem. They can tend to go high. My biggest problem is the voltage loss, which is measuring 39%. That's very bad. So that capacitor is shot. It's probably safe to say these are all shot. Even though the set worked, it's best just to replace them all. I know, it's not fun. I'm actually going to need to go to the museum and get some capacitors because I don't have enough here to do this. And plus I need some high voltage capacitors because some of these are 1,000 volts and you should observe that voltage because some of these do operate on pretty high voltages and you don't want your new capacitors to explode. So let me make a grocery list here and I'll go over there and get some stuff. Alright, the other electrolytic can is testing just as awful, even worse. 48% voltage loss. Alright, so made my list here of stuff I need. The rest of these are, there's only one high voltage cap I could find in here, which is this guy. It's a 2 ground capacitor. 0.068 at 1,000 volts. Everything else is like 400 volts peak, so it's not a problem. Anyway, I've got the CRT sitting over there, and I've got it sitting on a towel so it won't get damaged. I don't know what they put on the wiring back then. It was sticky and gross. So let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 paper caps here, and then 1, 2, 3, 4 electrolytics, 5 electrolytics, and then a bunch of like bumblebee caps on the circuit board in the front. It's not too bad. This is kind of like recapping a fancy AA5. It's not anything really based in rocket science. Let me see here. Again, tenth of a microfarad, 600 volts. There's nothing glamorous about that. I'm going to guess this is probably the across the line cap. Here's what did this go to? I can't tell. Could be coming off of the flyback, which would make sense. All right, I'm back from the museum, and I got a lot of stuff I can use here, including some terminal strips, because I'm going to have to combine some of these together to get the right microfarads. Like for example, I think one of the values was 150 microfarads. I can't remember. I think it was this one. So I'll need to put 3 of these together because you got 47, 47, 47. I know it's not exactly 150, but it's close enough. And we'll need to put them on these terminal strips so they're not all loose and wiggly and funny. I did find this 100 microfarad cap to replace, well actually I'm going to need to put this and one of these together to get 150 and 200 microfarads. I mean 150 microfarads at 200 volts. So let's get started with the recapping process. For some reason I always start with my electrolytics first and then go to my paper caps because these are more difficult and we'll need to find homes for them to live. I did get a bunch of self-tapping screws so that I can make it easier to mount these guys. I'm gonna have to be real creative with where and how I put things in this thing. Okay, so all the electrolytics have been replaced, and due to the spacing restraints, I wound up just tacking them onto their grounds as closely as I could. And you can see I have to double or even triple these guys up to get the correct microfarads. So there's 150 here, 100 there with 2 of those put together, and then these individuals are 20 microfarads each. And we have 150 microfarads here. And so all the electrolytics have been replaced, so now it's time to do the paper caps. And I did get a high voltage 1000 volt rated cap here for that guy, and the rest of them are just plain ordinary 300 to 600 rated capacitors, so no big deal there. Anyway, it's just a matter of what I do is I'll clip one end of one of the old capacitors and then clip one side of the new capacitor here and then clip the other and then do the same there, and that way you don't lose your place. Okay, so my back is going to kill me because I had to get down at weird angles to get these capacitors out of here, but they're all replaced. This one right here was actually the across the line cap. I didn't have anything that big, so I found this gigantic ceramic guy, and so that will hold up to any incoming surge. I don't want to blast that capacitor. So now I need to turn this puppy around and to have real tons of fun replacing the capacitors on this board, even though it might not be that bad because I can get to both sides of it. Well, this is going to be real fun. The challenge is going to be that the underside of the board has this shielding, and I'm hoping that they designed this in such a way where if I need to replace parts that I can just get to it. Like we have this capacitor here, and it looks like I could probably get to it. It's going to be a challenge, but whatever. I've worked on many pain in the butt things before, so what else is new? Alright, I'm partially done recapping the board, and I've been taking these guys off because I'm not familiar with what that is. I'm guessing it's paper, but I tested it and it tests good. It has a good ESR, very little voltage loss. I don't know. There's some of these that are very difficult to get at, if not impossible. So I'm going to try to replace as many as these as I can get to. And if there's some, like, the thing is I would have to do an awful lot of unassembling, meaning desoldering stuff just to get this plate off. And even then, it's like, I don't know. They obviously built the board and then assembled it into the container here. Luckily, we have quite a few orange drops here. Those are okay. We don't have to worry about those. And so I'll replace as many as I can here. And then when it comes to testing the set, it's going to do a real long-term test to make sure nothing, if there's anything left from the old caps, is going to go south. But again, I've been testing these guys coming out of circuit, and they all test good. So, but I don't know. I don't trust anything that old. All right, so I was able to replace most of the capacitors. The only ones I wasn't able to get at, again, because it would require taking all of this apart underneath, is these three. And they're the style that when I took out and measured, they measured good. So I'm just going to assume they're probably okay. The set did work, by the way. So electrically, I believe that's all it needs to be done. I do want to take the tubes out, clean them, clean their sockets, clean the pots. And then we'll start doing some cosmetic work on the cabinet, which is a little dirty. It's actually in pretty good shape. Maybe do some plastic polish on the lens, wherever it went. Oh yeah, it's stuck to the front of the CRT, sorry. So get this guy cleaned up, and I brought a converter. I'm not sure if it's going to work or not. I need an analog signal from digital. If not, we'll just see snow. That's okay. One of my friends over there says he's going to bring a digital converter next week. So, but as long as I get a picture, that means that the set still works. It'd be awfully bad if it stopped working because of my stupidity and making a mistake, which is a possibility. But I hope not. So let me just clean all these tubes and stuff. Is it necessary? No. But I like it. It, you know, thing's not been opened up in years. All right, so I got the chassis cleaned up. Again, is it necessary? No, but I like doing it anyway. And so now it's time to clean up my mess in the workbench and start doing some cosmetic work before we do some assemblage. Okay, now what I'm going to do is I'm going to get a damp rag and a little bit of simple green, and I'm just going to go over this whole case, get all the grime and crap off of it, and then probably follow up with some wax. I'll do this to this piece, as well as that piece, as well as what is attached to the front of the CRT. And no, I'm not going to undo the CRT. I'm just going to leave it there. Okay, so I've cleaned it up a little bit. I've got it outside. I feel like there's either a little bit of overspray or some gunk on the top of the finish. So I'm going to do is use this plastic polish. Maybe I'll be able to smooth this out a little bit. It's not the end of the world if I can't. It doesn't really show that much, but I'm going to use my mechanical buffer and use this polish and try to bring back the sheen. Okay, I succeeded in polishing up the case and got all the overspray off of the top here, so it's looking pretty good. Now it's the fun process of reinstalling everything, because it wasn't easy to take apart, but at least I understand how it goes back together. Alright, I'm coming into the final process of getting this back together again. I've installed the chassis, and again I'm protecting the yoke. And so I kind of like this thing here, this springy thing. It's a clever way of grounding the CRT or whatever. So let me stick this thing back together, and hopefully it'll still work. If it doesn't, I'm going to be like kind of upset. In fact, before I put it back together, I'm just going to check and look in here to make sure all of my soldering joints are good. Nothing's touching anything funny. Nothing's going to come loose. Alright, so let me put the CRT back in. Looks like the way it's going to work is I'll have the... Where is the anode? Here it is. Because you can extend this quite a ways out and then cook it to the CRT and then push the CRT through. Alright, it's now mostly assembled. Got the yoke back on. Everything is hunky-dory. Bring it up slowly on the variac. Make sure it doesn't destroy anything. Okay, it's drawing, but then it's falling back down. Is what I want to see. And what do we got here? Volts. 60 volts. Go ahead and bring it up because we don't have any old capacitors in there anymore. Got tubes glowing. Let's see if we get any picture. No picture. Oh, there we go. Oh boy, the yoke is crooked. Crap. Oh, I must have adjusted it, and I can't do that while filming. But that's good. I didn't fuck it up. But I do need to correct that yoke. It's crooked. Picture is like all crooked like that, see? Alright, well I know this is not filming right, but we got a good full CRT. I did some tweaking, not only with the pots back here, but there's some little pots you can adjust with a screwdriver. For what happened is after I overhauled it, for some reason, it wasn't filling up the entire bottom of the screen, but now it is. Boy, it looks strange. Why can they not figure out how to make cell phones able to shoot CRTs? That doesn't make any sense to me. So now I'm going to put the back on. And when I want to run an analog signal through it to see if I get any picture.